So today we're going to cover Chapter 3, Section 3. Today we're going to learn how to prove that lines are parallel. So we are going to take all of the information here that we learned yesterday, all the theorems, and we're going to switch the order and turn them into converses. So the first one is called the corresponding angles converse theorem. And this one states that if two lines are cut by a transversal and corresponding angles are congruent, then you can prove that the lines are parallel. So in this particular picture, I can see this particular diagram. I can state that if angle 2 is congruent to angle 6, then I can prove that J is parallel to K. So what you're going to be looking for are the special angle pairs. And if you have corresponding angles that are congruent, alternate interior or alternate exterior angles that are congruent, you can prove the lines are parallel. And then remember, consecutive interior angles will be supplements. So this is using the corresponding angles converse theorem because I've got congruency marks on angles 2 and 6, which are corresponding angles. So the 4 theorems we learned yesterday, we're taking all of those and flipping the if and the then, and we're going to turn those 4 theorems into converses today. This is the first one. The next slide will have 2 more. 2 more. The first one is called the alternate interior angles converse. And this one states if 2 lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. The same for the alternate exterior angles. If you can show that 2 lines are cut by a transversal and show that the alternate exterior angles are congruent, then you can prove that the lines are parallel, and this would be using the alternate exterior angles converse. I'm going to go ahead and add in a diagram and add some congruency marks so we can give a statement that is specific to the diagram. So I've got 2 lines, P and Q. My transversal is in red. I'm going to add in the 8 angles. So 1, 2, it doesn't matter how you number them. So I'm going to do 1, 2, 3, 4, and then 5, 6, 7, 8. I'm going to go ahead and add in some congruency marks. So I'm going to add a congruency mark to angle 3 and show that it's congruent to angle 6. So my first theorem states if 2 lines are cut by a transversal and alternate interior angles are congruent, then you can show that the 2 lines are parallel. So what I'm going to state here is if angle 3 is congruent to angle 6, then I can prove that P is parallel to Q because 3 and 6 are both alternate interior angles. Now, we could also show that 4 and 5. So you could also have said if angle 4 is congruent to angle 5, then you could also show that P was parallel to Q because 4 and 5 are also alternate interior. Let me go ahead and add congruency marks to a pair of alternate exterior angles. So let's say I add a congruency mark to angle 2 and angle 8. So for this one, I could state that if angle 2 is congruent to angle 8, because they are congruent alternate exterior angles, I can show that P is parallel to Q. Now, there's another pair of alternate exterior angles here. You could have also said if angle 1 is congruent to angle 7, then P is parallel to Q. So you just need to find one pair of alternate exterior angles with a congruency mark, and then you can show that the lines are parallel. And this is using the converses. So the next one is called the consecutive interior angles converse. And this one states, if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So again, I'm going to draw a picture. I'm going to draw my two lines. Again, I can name them P and Q or A and B. It really doesn't matter. Just use P and Q. I'm going to draw in my transversal. I can add in my 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. Again, it doesn't matter where you put the numbers. So let's say for this one, I told you that the measure of angle 2 was 110. Zoom in here a little. And let me tell you that the measure of angle 3 is going to be 70. So because I can show that 110 plus 70 equals 180, this tells me that angles 2 and 3 are supplementary. So I could show that P is parallel to Q by using the consecutive interior angles converse because I have a pair of supplementary angles. So my statement here would be, if angle 2 and angle 3 are supplementary, then P is parallel to Q. And this is using the consecutive interior angles converse. The next one is a property. This one is called the transitive property of parallel lines. And this one states, if two lines are parallel to the same line, then they are parallel to each other. So we've already seen the transitive property for algebra. We've seen it for segments, showing congruence or equality. And we've also seen it for angles. Now we're going to see it to show that two lines are parallel. So again, let me draw in a picture here. I'm going to draw 3 lines. Now they don't necessarily need a transversal in here. Just know that we could call this J, K, and L. So if I tell you that J is parallel to K and K is parallel to L, then you can conclude that J is parallel to L. So let me write this out in letters here. So you could state that if J is parallel to K, and if K is parallel to L, then you can say that J is also parallel to L. So notice they're both parallel to the same letter. See the overlap here? So then you can conclude that the first one is also parallel to the last one. So that middle part blends together. All right, so there are actually 5 ways because 2 has 2 things in it. These are the ways to prove that 2 lines are parallel. So the first thing you can do is show that you have a pair of corresponding angles that are congruent. This is using your corresponding angles converse. Then the second one is to show that you have a pair of alternate interior angles or alternate exterior angles that are congruent. So for number 2, showing the alternate interior, this would be the alternate interior angles converse. And then the other way is to show alternate exterior angles are congruent, and this would be your alternate exterior angles converse. The third way is to show that you have a pair of consecutive interior angles that are supplementary. So this way would be to show that we are going to use our consecutive interior angles converse. So once we have a pair of angles that are supplements, we could prove that the lines are parallel using the converse. And then lastly, show that both lines are parallel to a third line. And this is our transitive property of parallel lines. So transitive property of parallel lines. I'm going to just use the symbol for parallel there. In the next section, we're going to learn one more way to prove lines parallel, and we'll bring in our knowledge of perpendicular, but that'll be coming in the next lesson. All right, first example wants us to try to determine which segments are parallel. Now on the previous slide, we just saw the four ways. So here, first thing I'm gonna look for is to see if I have any congruent angles. Notice all of my numbers are different. But what if I reach back to chapter 1 and use my angle addition postulate and add up the 24 and the 36, and I get 60. So now this angle, CAB, is equal to 60 degrees. And then if I do the same thing over here and add up 22 plus 38, I also get 60. So now I actually have some congruent angles. So this is actually angle EBG. So because angle CAB, and you could go in reverse, you could also name it BAC, because that angle is congruent, and again I could do it in reverse, GBE, because they're both 60, I can see that I've got a pair of corresponding angles that are congruent. So I can show, and again, to figure out where the transversal is, you're going to look for the line segment or the line that has both colors. This is the transversal. And then the parallel lines would be the EB and the AC, where the single colors are. So my parallel lines here would be AC is parallel to BE. And again, you could write it in reverse. You could say CA, EB, it doesn't matter. And what I'm using here is because I found a pair of corresponding angles that are congruent, I am using my corresponding angles converse. You use the converse when you're proving them parallel. But yes, we could also include the line on top to indicate that these are segments here, because that's what they had asked. If they asked for lines, you would put the picture of the line on top. So here I am using the corresponding angles converse, because if corresponding angles are congruent, then the lines are parallel. So I showed that they had to both equal 90. So my equation was x plus 40 equals 90. I subtracted 40 from both sides and found out my value of x was 50. Now tomorrow, we're going to learn a theorem called the lines perpendicular to a transversal theorem. And what this is going to state is if two lines are perpendicular to a third line, which is the transversal, then the two lines are parallel. So this would be another way that you can do it after we learn 3/4 lesson that you could use on the test. But for the quiz, we don't know that yet because we're only going to cover 3, 1, 2, and 3 for the quiz. All right, so for this one, it wants us to find the values of x and y that make j parallel to k and L parallel to T. So if I go ahead, I'm going to work with the JK first. So if I want to show that J is parallel to K, I'm going to bring in this line L as my transversal. So notice I've got some angles here. I've got a 60 and a 3x. These are a pair of corresponding angles. So because corresponding angles will be congruent in order to prove lines parallel, to find my value of x using my corresponding angles converse, I'm going to set up the equation of 3x equals 60, divide by 3, and x equals 20. So this would be using my corresponding angles converse, and then I can show that J is parallel to K. Now I'm going to redraw the picture to show that L and T are parallel. You redraw the picture. And I've got L and T here. And then J and K. So this time, I want to show that L and T are parallel. I'm going to add in where I have the values. So I've got a 2y here and a 60. And then I also had the 3x, which I already found. So for this one, I'm going to use J as my transversal. And notice this time, I've got a pair of alternate interior angles that are congruent. So to show that L is parallel to T, I'm going to be using my alternate interior angles converse, and the value of y will be 2y equals 60, divide by 2, and y must equal 30. So here is a picture of a diamondback snake. They've taken a portion of it here, and then they've enlarged it over here. So let me go ahead and zoom in here. So we've got our lines and we've got some angles that are marked as congruent. Let me go ahead and outline this in maybe a color that'll show up a little bit better. So I have this side, and then I've got my transversal, and then I've got some congruent angles marked here. So in order to show that those green lines are parallel, what kind of angles can I identify here? What are the yellow angles? Anybody notice? Perfect. So they've got congruency marks. They're inside those green lines. So they are alternate interior angles. So what we could state here is if alternate interior angles are congruent, then the lines would be parallel. And that's what I have pictured here. So I'm using my alternate interior angles converse to show that those green lines are parallel.